Hi, good morning my dear students. Welcome to the chemistry class. So in the last class we have completed the second chapter. So that is periodic classification. I hope successfully we have completed two chapter. According to me, I thought that you are not having any doubts. If you are having still doubt means I am giving you the chance. So feel free to ask any doubts. And most of your friends have sent the notes. Only few you are there and sent. So for your kind information, for this chapter, I may send you some of the definition and explanation. I am going to send only for those who are sending me the notes or the assignment. Only for them I am sending the notes. Keep in your mind. One thing. And second one is, so whichever I have completed that first chapter and second chapter, so I will give you some important questions based on that two chapter once again. So try to solve that one and write that in an assignment. Okay. So let's begin the third chapter, that is states of matter. So in this states of matter, you already know the matter is nothing but which occupies space and have mass. In the last classes also we have dealt about the matters and all. So here purely we are going to deal in depth about the matters. So let me clear you. So we know that matter is nothing but which occupies space and have mass. I hope now onwards you will never get any confusions regarding the mass and weight, because in the very first chapter we discussed about the mass and weight. Mass is different and weight is different. So here, any object or the substance which occupies space and have mass is called as a matter. For example, this chalk, initially my palm is empty, it is having space. After keeping this on my palm, so it means it is occupying the space. So which occupies space and have mass, this is called as matter. So this is basic thing. But in this first PUC, we are extending this definition of matter classifications. So here, no doubt, matter exists same in the three states, that is solid, liquid and gases. In the previous educations, you have classified the solid, liquid, gases on the basis of arrangement of the particle. So in the solid, the particles are tightly arranged, and liquid loosely, and in gases it is freely undergo movement. So here we are going to define solid, liquid, gases on the basis of some different terms. Just begin what are those terms? There are two forces are arising, that is intermolecular forces, and one is thermal energy. So let's start that too. So as I said, in the matter it exists in three states, that is solid, liquid, gases. What is solid, what is liquid, what are gases? That will be defined on the basis of the two forces. On the basis of two forces. In that two forces, the first one is intermolecular force. Commonly we are calling that as intermolecular force. But keep in your mind that intermolecular force itself is an intermolecular attractive force. Why? Because whichever we are discussing the force in the intermolecular force, that all force are going to explain about the attractive. But in definition we are saying that intermolecular force are nothing but they may be attractive or repulsive forces in a molecule. Actually, intermolecular force we are going to discuss only about the attractive forces. For that reason we call them as an intermolecular attractive force. So it will help you to understand for defining the further solid, liquid, gases. That's why I am writing the attractive between this intermolecular force. Here, intermolecular force or intermolecular attractive force. Here it is same. So intermolecular attractive force are nothing but these are the force present in almost all of the matter. It may be a solid, it may be a liquid, or it may be a gases. So here these molecules which are having the force, this force always makes the particles closer to each other. For that reason it is called as intermolecular attractive forces. So sometimes we may say that some of the intermolecular forces, they may repulse the molecules each other, but we are having separate classification for such kind of forces. So look here, in intermolecular forces we we are discussing mainly three type of the forces. The very first force is, we are not defining that one. So almost all intermolecular forces, they are undergo the van der Waals force. They are undergo the van der Waals force. Van der Waals force. So here, what is that van der Waals force? Van der Waals force is one of the weakest force, and it is present in almost all the particles. So van der Waals force is nothing but it is under the attraction. So just think that. So after rubbing some of the choppies, so can you see here? This choppies is tied on my fingers. Even though if I rub means it's not going. Sometimes it's not. Or some of the dusters may deposit on my shirt. So if I simply making this in this force, so it will move. So it means these are very negligible force which is present in almost all particle. Such kind of force are called as van der Waals force. So among all the attractive forces, the weakest force is van der Waals force. So this force exists almost all particle, but it is negligible quantity. The force is almost negligible, but van der Waals force exists for the particles which are undergo attractions. So power went. Soon I will continue. Wait for a second. So we were discussing that van der Waals force is the weakest force which attacks the molecule. We are not giving a separate classification in the intermolecular forces for van der Waals force. Why? Because it is the weakest force and it is almost present in all of the particle. For that reason, we are not giving the separate classification for van der Waals force. Keep in your mind, it doesn't mean that it is not important. It is important, but it is present. But we are not giving the classification. No doubt that you just can able to remember that van der Waals force is the weakest attractive force. So coming to the first one, dispersion force or London force. The first one is dispersion or London force. So this is the first force which is attracted by the molecule. For that reason, the dispersion force or the London force, these are the forces which attracts the particle, in a state because of one of the weak force, but these forces are undergo the force of attraction between the temporary dipole moment. What is that dipole? So I said the dipole is nothing but if the particles are, for example, simply I am telling you, sodium chloride, sodium carry positive charge, chlorine carry negative charge. In this type of compound, can you see here? If I draw this in this way, at one end we are getting positive, at another end we are getting the negative. So if the two poles means two ends, some end means some pole carry positive charge, another pole carry negative charge. Pole is nothing but end, terminal point. Here there is a separation of two poles. For that reason we are calling that as dipole. So dipole is nothing but the molecule should undergo the different charges at opposite side. If one carry positive, another end should carry the negative. That creates the dipole. Wherever we are generating the dipole, there exists that compound we are calling as a polar molecules. So polar are nothing but the substance which undergo the dipole. That the dipole molecule itself is called as polar molecule. Can you see here? Sodium chloride is carrying some end is positive, some end is negative. Means sodium is losing the electron, whereas chlorine is receiving the electron. Number of electrons are more towards the chlorine and less towards the sodium. That is the meaning of this dipole. One end carrying positive, another one is carrying negative. Means at one pole it is electron deficient. Keep the word deficient. Deficient is nothing but the number of electrons are less. That is called as deficient. The number of electrons are less. That is called as deficient. If the number of electrons more, we are calling that as a rich electron. Here rich is nothing but number of electrons are more towards some end. That is called as number of electrons rich. At one pole, number of electrons is less. That is called as electron deficient. And this is electron H. If that creates, that is called as dipole. Here, dipole, are you getting this one? If this dipole, they are not originally dipole. If that dipole is generated by the temporarily is matlab how? Look here. Generally, the structure of atom is spherical. Nucleus will be present at the center. So this means what? The nucleus is present at the center and electrons which are presented around the nucleus, they are distributed uniformly. They are distributed uniformly. Can you see here? The nucleus is at the center and electrons are revolving around the nucleus. In this figure, as you are observing here, the electrons are distributed uniformly. Means the electrons are present almost all the sphere, not at one end. Means dipole is not creating. It is not electrons are coming at one end and nucleus is not moving at the another end. Can you see here? If the same compound, if I make this non-polar, this is non-polar because it's not creating the dipole. This is non-polar. If I bring this non-polar to another polar compound, just take this. It may be any other compound which is carrying the dipole. That is called as polar compound. Are you observing this one? This is polar, means this is the dipole. It undergo dipole. I hope you can now never get any confusion. Dipole is nothing but it is having separate charges at two ends. That's why it is polar. This is non-polar. This is a dipole molecule. This is non-dipole molecule. Are you getting this one? Look here, what happens? Initially, it is the electrons are surrounded uniformly. There is no generation or partition between the positive charge and negative charge. So when this non-polar compounds are bring towards the dipole molecules, towards the polar molecule, at that time there is the attraction between the oppositely charged molecules. Can you see here? In this dipole, we are bringing this negatively charged pole. Is it clear? Negatively charged means to which charge of this compound will be attracted to this pole. Because it is a negative, it has to be attracted only for the positive. At that condition, what happens? Look here. This is the negative. So this shape will be changes and it creates another temporary polar compound. Initially it is a non-polar, but it is converting as a polar by another compound. Means this is not the permanent. These are the permanent compound. This is not permanent. So after this negative and this is positive. The same compound I am brought here. Dipole is not the dipole. What happens here? The nucleus will come towards one end and electrons will shift to the another. Means this pole carry the more electron. That's why I can draw this as a negative, and this is the less number of electrons. That's why it is called as positive. Can you see here? Initially it is not polar, now it is polar. But this polar molecule is not a permanent molecule. Once I remove this dipole from this non-polar, again this is going to form as a non-polar state. So such kind of compound, these are not a permanent dipole compound. These are not the permanent dipole moment compound. Such kind of compound may exist some of the attraction between the dipole of temporary force. Dipole of temporary force means here, can you see here? The force of attraction between the dipole, that is temporary force between the dipole. Such kind of force is called as dispersion force or London force. Are you getting my point? This is the definition you have to remember. So dispersion or London force is nothing but it is a force of attraction between the dipoles of temporary force. Are you getting my point? So dipole, which is temporary for the present. Dispersion and London force is a force exerted between the dipole molecules of temporary force. Why? Because these polar are not permanent. Are you getting my point? Coming to the next one. I hope you can understand this definition. Here, they will not ask you the next point which I am explaining to you, but you should remember at least for the competitive exams. So I will help you for annual exams for your first year or second year. This term will be continuous, but which I am explaining right now. it will be asked from the competitive exams like CET, NEET, JEE. For that reason, you have to extend of this one. So here dipole temporal force, that is dispersion and random force. These forces are inversely proportional to the sixth power of distance between the two dipoles. I draw here one dipole, another one is dipole. Plus minus and minus plus. Is it clear? The distance between the two dipoles. This distance between the two dipoles is called as r. R is nothing but distance between the two dipoles. The sixth power is r raised to 6. That is in the reciprocal inversion. It is. Can you see here? Dispersion or London force is the force which is inversely proportional to the sixth power of distance between the two dipoles. So means this force is how it is undergo the force, means capacity is undergo the, this force is how it proportional to the distance between these two, means between these two dipoles the force is exerted. To what extent the force is depend, means it is inversely proportional. Means if distance is increased means dipole forces will be decreases. Can you see it is inversely proportional? If distance reduced means it means dipole London force will be increases, and it is same. This is also negligible of the force, but you should remember that dipole and dispersion and London force. This is the force inversely proportional to the sixth power of distance between the two dipoles, that is r, where r is the distance between two dipoles. Are you getting this one? You have to remember this term. This is for competitive exams, and the definition is important for your theoretical exams. So coming to the next force, that is dispersion force and London force. First one. Next one is dipole force. Second one is dipole force. Based on the heading, you can able to understand what is this force. This force is between the dipole. Such kind of force is called as dipole force. But here it is between the dipole only. But those dipoles are not the permanent. Those dipoles are having the force that is temporary force. Are you getting? That is called as temporary force. Not the, we are not calling that as dipole is not temporary, but we are calling that as a force is temporary. The force of attraction between the dipoles of temporary force, that is called as London. Whereas here the force which is exerted means force of attraction only. This is the force of attraction between the permanent dipoles, between the two permanent dipoles, that is called as dipole interaction or dipole force. So it means the same as I drawn in the previous. So these are the two dipoles. This is also permanent dipole and this one is also permanent dipole. The positive has to attract towards negative, or in other words, negative has to attract towards the positive. Are you getting this one? So the force of attraction between the two permanent dipoles are called as dipole force. Dipole force. Here, what happens is these dipoles may undergo the rotation. This rotation. Means these dipoles are undergo the rotations. They may undergo the rotations. Can you see here? This may undergo some rotations. This dipole may undergo the rotation. If it one rotates, obviously the second one has to be rotated because they are undergo some force of attraction. For that reason, only in the dipole forces they are, and this dipole forces there is a rotations between the dipoles or rotation across the axis. For that reason, we are defining this, how this dipole forces depends on the distance between two dipoles, that is r. We are defining on the basis of two factors. One is when the dipoles are at rest in the sense stationary in the sense they are not rotating, then it's called as stationary. The dipole forces at stationary is having different proportion, at the rotation it is having different proportion. So first one is the dipole forces. I hope you can understand that one. The force which is exerted means the force of attraction between the two permanent dipoles are called as dipole forces. So here The dipole forces for stationary. Stationary is nothing but when they are at rest. Here, stationary is nothing but when the dipoles are at rest. They are not undergo any rotation. Then it is called as stationary. When the dipoles are undergo stationary, at that condition, dipole force. This dipole force is proportional to the reciprocal of or inversely proportional to the third power of distance between the two dipoles. Can you see here? This is R is nothing but distance between the two dipoles. That is R. So it means that dipole forces are inversely proportional to the third power of R. Third power of R. R is nothing but distance between the two dipoles. R is to 3. Now you get this one. When it is this force is proportional to 1 upon R is to 3 means at this condition the dipoles are not rotating. It is stationary. If they are rotating at that condition, dipole forces are inversely proportional to the same sixth power of distance between two dipoles. Sixth power of distance between two dipoles. Are you getting my point? When they are at stationary, the proportional is 1 by R is to 3, and at rotating, the proportional is 1 by R is to 6. Are you getting? In dipole, they may undergo rotation or they may undergo stationary. Based on that, we may define the proportional force, that is 1 by R is to 3 for stationary, 1 by R is to 6 for rotating. Are you understanding this one? So, according to me, these two terms are important for your examination point of view. They may ask such questions. What is the proportional dipole forces in a rotating or stationary? So this is second one. The third one is dipole induced dipole force. Dipole and induced dipole force. Induced dipole. This seems to be a similar to the first one, but it is not same definition as first one. No doubt, dipole induced dipole is going to explain the same as we explained in the discussion of London forces, but it is having different meaning. Keep in your mind. So here, what happened is, so I said in the London forces there is a temporary force between the dipole. Temporary force between the dipole. Whereas here, one is a permanent dipole, one is not a permanent dipole. One is the dipole created by the dipole. So, as I explained in the London force one day, but in the definition we are not saying that one is permanent dipole and one is not a permanent. We are not used such kind of words. So it means there is a force between the dipole. That force is temporary. That force is temporary. That is called as London force. Whereas in dipole and induced dipole, what is a dipole? One is a permanent dipole. Are you getting this? One is a permanent dipole. Whereas another one is it is not a dipole. It is just like spherical. It means it is not undergo any dipole. It means it is non-polar. So this non-polar, or which one is a non-dipole, when it moves towards the dipole, so by the effect of this dipole, this non-dipole also creates a dipole character. It also creates a dipole character. Other condition, one is a permanent dipole, another one is a induced dipole. Induced means that is not a dipole, but it is appearing and it is generating the dipole character by the presence of another permanent dipole. Such kind of force present between the permanent dipole and induced dipole. That force is called as dipole induced dipole forces. Are you getting my point? Dipole induced dipole force is a force which is present between the force of attraction between permanent dipole and induced dipole. Permanent dipole and induced dipole. That is called as dipole and induced dipole forces. Are you getting my point? So after coming nearest to the permanent dipole, that another non-dipole is forming as a induced dipole. So when I remove this permanent dipole, again it is going to make it a spherical only. Means the dipole will be destroyed. For that reason, dipole and induced dipole we are going to. Here also the force of dipole, individual dipole force is proportional to the 1:6, means inversion of or reciprocal of sixth power of distance between two atoms or the molecule. Between those atoms are one is dipole and one induced dipole. Means the force of dipole and induced dipole force are inversely proportional to the sixth power of distance between two dipoles. You can say that as two dipoles because one is dipole, another one is also dipole, but it is the induced dipole. That's are you getting the point? The force present between dispersion and induced. Can you say dispersion and London and the dipole induced dipole both are having 1 by r/6. Here also dipole are having, and the rotation only it is having 1 by r/6, and stationary it is having 1 by r/3. Are you getting my point? So these mathematical expressions are important. What is the proportional of force? They may ask such questions. So keep in your mind the definition is important. What is London force? What is dipole force? What is dipole induced dipole force? It may ask for you. So these three are the, is including that van der Waals force, but we are not saying that. No doubt, keep in your mind van der Waals force is also a kind of intermolecular forces or intermolecular attractive forces. These are going to attract the molecule. If sometime they ask you what is intermolecular force, means the force which is force of attraction or repulsion between the molecule or atoms in a compound. In compound, the attraction or repulsion together is called as intermolecular forces. But keep in your mind, but we are discussing the intermolecular force only about the attractive, not about the dispersion. Why? What about does it not have any repulsion between the molecules? Exactly, it is having some repulsion, but we are calling such different force for the repulsion. It is not having any classification, but we are calling that as only one kind of force. So initially I said intermolecular force of attraction, it is having the van der Waals force, dispersion, that is London force, dipole force, dipole and induced dipole force. Whereas second one is thermal energy. Second one is thermal energy. The first one is intermolecular force, second one is thermal energy. Keep in your mind, intermolecular forces are nothing but these are the force which makes the particles near to each other. Whereas the thermal energy, these are the energy or this is the force which make the particles away from each other. Means wherever the thermal energy is present, there is a repulsion between the molecule, whereas wherever the intermolecular force is present, there is an attraction between the molecule. Are you getting my point? So I hope now onwards we can able to define this one. What is thermal energy or what is thermal force? Both are same. Thermal energy is a force which creates a force of repulsion between the molecules, force of repulsion between the particles in the molecule. Are you getting this one? Wherever the thermal energy is there, based on that we can make the particles are apart from each other. Are you getting my point? Thermal energy is a force which tends to keep the particles away from each other. That is called as thermal energy. So based on this, we are going to define the states of matter by these two terms. One is intermolecular force and write as short intermolecular force or intermolecular attractive forces. Don't write this one, simply for my convenience to make it clear. That's why I have written intermolecular attractive force. Another one is thermal energy. So let me tell you, solid is converted into liquid, liquid can be converted into gas. How can we convert that one? Means based on arrangement, if the solid can be converted into liquid and liquid can be converted into gases, particles are here near to each other, here little bit going forward, and in the gases the particles are very forward, isn't it? So now tell me, in solid which force is greater? Come on, speak about yourself only, so that your soul can understand the concepts of soul. In the solid, the particles are near to each other. It means that inter-attractive forces is greater. I say to you, all the three states are having both the energy, that is thermal energy and inter-attractive forces. Both energy, both forces, they are present in almost all the matter. But based on how much quantity is present, based on that we are defining the solid, liquid, gases. The definition is very simple, very easiest one. Look here. The matter which is having in the solid intermolecular attractive forces are greater. Why? Because the particles are near, it means the attractive forces should be greater. It is greater than the thermal energy, isn't it? Greater than the thermal energy. Are you getting my point? Whereas in the liquid state, the particles are slightly near, not lightly arranged. Therefore, intermolecular attractive forces are near to the thermal energy, means it is slightly greater than this thermal energy. Whereas here the particles are far away, it means that we can say that thermal energy is greater than the intermolecular attractive forces. Are you getting my point? So based on this, now I am going to define it. Look here, this is important for defining the solid, liquid, gases for you people. What is solid? What is solid or defined solids are what? The matter in which intermolecular attractive forces are predominantly, means considerably, maximum, predominantly is nothing but almost it is greater. The matter in which intermolecular attractive forces are predominantly greater than the thermal energy, such kind of matters are called as solid states. Whereas a liquid state is nothing but it is a matter in which intermolecular attractive force is slightly greater than, slightly means it is just greater than the thermal energy, not having larger difference. So here intermolecular attractive forces is slightly greater than the thermal energy. Such kind of particles are called as liquid state. That's called as liquid state. Whereas gaseous compounds are nothing but here intermolecular, this is T. T is nothing but the thermal energy. The matter in which thermal energy is predominantly greater than intermolecular attractive forces. Such kind of matters are called as gaseous compound. Are you understand my point? This is very clear. In solid, intermolecular attractive forces are predominantly greater than the thermal energy. In gaseous, thermal energy is predominantly greater than the intermolecular attractive forces. Whereas in liquid, intermolecular attractive force is slightly greater than the thermal energy. Based on this, we can able to define the solid, liquid, gases. Are you getting the point? Do watch it once again. Understand the definition. The moreover defining solid, liquid, gases based on this shape. It is attractive. This is repulsive. Are you getting? And I hope you can able to easily give the example for solid, liquid, and gases particle. So you can say stone, salts, these are the solid, and liquid, water, oil, these are the liquid, and gases you can give the any example for the gaseous molecule, that is hydrogen, oxygen, nitrogen. But they will not ask you, but you should know these all things. Okay, so this is a brief beginning of states of matter. So matter definition you should know, and that can be classified into two terms, that is intermolecular and thermal energy. I hope in intermolecular attractive forces there are again three. You can say that four: van der Waals, dispersion, dipole, and dipole and individual dipole. And in thermal energy, it is only the repulsion between the particles. So by this explanation, we will in detail about this chapter in the next classes. If you are having any doubts, you can ask me. So we will meet in the next week. Have a nice day. Bye.